Okay, 1.4 angle measure. Objective. Students will be able to find the measure of angles and classify angles. We're going to have to define some things here. A degree is 1/360th of a turn around a circle. That way if we have a whole circle, and here's the center, and let's say I was to start with that ray and go all the way around, that would be 360 degrees. So 1 degree is just 1/360th of a turn, because that's 360 degrees all the way around. So 1 degree would just be 1/360th of a complete turn. A ray, this is a part of a line with one endpoint, and all the points to one side of that endpoint. If you look here, we start with H and we go this way through G, or we start with A and we go this way through B. Unlike a line, order matters, so we always start with your endpoint. Remember, with a line, we said we can name it either way, but with these ones, you have to do it a certain way. So here, this is HG. You have to start with wherever the ray starts, and then you draw a little one-sided arrow on top of it, indicating that you started with the H, start with the H, start with the H, go through the G, go through the G. See how that works? Why don't you see if you can name AB real quick? And you may want to pause the video because I'll put the answer up in just a second. Yeah, so you should have named this as ray AB, start with your A and go through your B. So that's how you should name that one. So what do you notice about how a ray is written? Just that the order matters. That's the main thing I want you to pick up there. So let's take a look at this one. This is example one. Name all the rays you can find. Well, let's just use the ones that are already on here. I see Vx, so starting at V, going through X. And it's okay that V is already on a line because the ray it's part of a line. So Vx is a ray. Then I could go backwards and say, hey, Xv is also a ray. I see Vz is a ray. Ux is a line segment, Xy is a line segment, and Uy is a line segment, so we don't have a ray drawn. However, we could say that there is a ray that goes like through from X through Y or from U through Y, but it's not drawn, so we're just not going to really worry about it. So those are the three that are drawn. Then it says name the two rays with endpoint V. Well, I'll let you guys try and do that, but here's your endpoint V. See if you can name those two real quick. I've already named all three of the rays, so name the two that have an endpoint V. Let you pause the video if you want. Okay, so obviously this one and this one have an endpoint V because they both start with the letter V. Okay, so opposite rays. These are two collinear rays, so collinear meaning they're on the same line, with the same endpoint. Two opposite rays form a line. Look, here we have AC is a ray and AB is a ray, and notice that when you put them together they make a straight line. So we could say that AB and AC are opposite rays. Okay, now let's talk about angles. So an angle is, we use this little notation right here to represent an angle. Notice it looks like a little angle. This is a figure formed by two rays. So whenever we're talking about angles, we're really talking about at least two rays. See, here we have a ray and a ray together. They have a vertex. A vertex is the corner. These are the sides of the angles. Here we have a ray, and the angle is this little guy right inside there, that little angle, the little corner, that's the angle. We call this point that represents the corner, we call that the vertex. And yeah, that's it for defining an angle. Okay, on the previous page we have this angle, AVB, so it looks something like this. I know my drawing's not so great. A, V for our vertex, and then B is over here. Okay, I know that was on the previous page. I'm just redrawing it here so we can talk about it, because we're going to talk about different ways to name an angle. And the first is just by using the vertex, V. So we could just say, hey, you know what? V is right in the center. This is angle V. The problem with that is, what if I was to draw in another ray here? call it C. Now this suddenly isn't specific enough. I don't know if you're talking about this angle here that we had initially, or this new huge angle here, which is both of those angles combined when you say angle B. So we're going to need a different way. Another way that you might see is, you might see somebody went and put like little numbers in here and just call this angle 1 and this angle 2. So that's one way you could do it. So that's our number 2. It says the number. Sometimes there's a number written in the angle, and so we just refer to that angle as, so the same angle that we were talking about above would now just be angle 2. Put the little angle symbol and then 2. By the way, that's the little angle symbol that we saw on the previous page. Then there's this way, point, vertex, and point. This is what we use if we don't have little numbers here and we don't know how to specify. So let's say I want to talk about the angle that's has the two sides that are black here. How could I name this angle? Well, I could do a point from one ray, the vertex, and then a point from another ray. So angle 2 could also be called angle AVB. And it's very important that the vertex is in the center. Notice here it says angle 2. It might be, I don't know if you're looking at this drawing because we have angles 1, 2, and 3. So if I was talking about angle 2 here, I would call this one angle AOB, because A is on the side, O is the vertex, B is on the side. So let's go down here and let's talk about some things. It says, hey, XOA and AOX are the same angle. That's true. XOA, AOX. It's the same angle. It's like lines. It doesn't really matter which order you go in, but the O is in the middle. It has to be in the middle because it's the vertex. But you could call it out AOX or XOA. All right, let's talk about practice number 2 here then. So if that's true, what's another name for angle AOB? And don't use angle 2. Just give me another way to write angle AOB. And then maybe you should also think of a way to name angle 3 here, angle 3. So go ahead and do this. You may want to pause the video because I'll put the answers up in just a second. Okay, another name for angle AOB is angle BOA. You could just go backwards as long as the O is in the middle. And another name for angle 3 would be angle BOY, right? Angle boy. Or you could go the other direction and say angle YOB. All right, now that we've talked about how to name angles, let's talk about measuring angles. Uses the protractor postulate when we measure angles. It's just the difference between the two numbers of each ray is the measure of the angle. So if we put a protractor on, we'll usually start at 0 and go to 180. But sometimes you might have an angle that starts, right here and ends here. Basically, you just take whatever number this one is on, whatever number this one is on, and if you want the measure of the angle between, you just subtract the two numbers. Obviously, it's easier though if you start at 0. Let's say this was going to like 43 degrees, and this is started at 0. We could say, hey, this angle measure here is from 0 to 43. Well, the difference between 0 and 43 is 43. So this one would be 43 degrees. Let's play with it a little bit more. I'll show you what I'm talking about. Here we have an example number 3. So it says first find the measurement of angle SON, or SON. So let's look at it. We have SON. You know what? I'll even underline it in blue, and then I'll highlight this guy in blue so we can see it. All right, so there's SON. And we can see that it's on top of a protractor that goes from 0 to 180. Protractor is how we measure angles. And we see that SON starts at 0 and goes to 40. Well, the difference from 0 to 40 is just 40. So this one is obviously 40 degrees. Let's do this a little bit trickier though. Do it in red. Angle ROT. I'll draw it out here. R and T. Okay, this one's a little bit trickier. We're starting at R. Or we can start at T, it doesn't really matter, but let's start at R. And we see that we're starting at 160, and then T is at 70. So we just need to quickly figure out the difference from 160 to 70. Let's go over here. It's going to equal 160 minus 70. Well, what is 160 minus 70? It's 90. So angle ROT is 90 degrees. And when something's 90 degrees, we can add in this little square, and that's how we say, hey, that angle right there is 90 degrees. It's a right angle. That's how we say that. All right, so I'm going to let you guys figure out what angle MOE is. Let you figure that out on your own. See if you could do that one. MOE is right here. You may want to pause the video because I'll put the answer up in just a second. Okay, well, MOE, as you look, M is at 180 and E is at 105. So really, you just need the difference. I'm going to write it right underneath here from 180 and 105. 180 minus 105 is 75, so it's 75 degrees. That's your answer. That's supposed to be a little degree symbol, but my handwriting's horrible. All right, next up we're going to just talk about classifying some of these. These are pretty easy. You've probably heard these terms before, so let's just talk about them. First one, anytime we have an angle that's less than 90 degrees, a small one, we call it acute. I like to think that it's a cute little angle. Right? That's just kind of how I remember it. It's dorky, but it works. All right, the next one. A right angle, this should be something you're familiar with. We use this a lot in geometry, and you just see these all over the world. Like, you know, windows, doors, buildings are all built with right angles in them. Everything has right angles, so you'll see these all the time. Let's go to the next page. The other thing that we have is an obtuse angle. This is when it is more than 90 degrees. See how big this angle is, how it's wider than 90 degrees? The way that I remember this is obtuse kind of reminds me of the word obese. So I think of this as an obese angle or an obtuse angle. So that's kind of how I connect those, because it's kind of a fat angle, right? It's a little bit big. So that's anytime it's bigger than 90. Now technically it also should be smaller than 180. And that's the next angle we're going to talk about over here. This is a straight angle, because a straight line always makes 180 degrees. And so once it gets up to here, we just call it a straight angle. We don't really call it obtuse anymore. So those are the different types of angles. So the last thing I'm going to have you guys do on this video before the summary is see if you can classify some of these angles. So I'm going to let you guys just do these four on your own. We have 4, 5, 6, and 7. Here's your drawing. See if you could tell me if these are acute, right, obtuse, or straight. I'll let you fill each of these in, and then you may want to pause the video because I'll put the answers up in just a second. Okay, I tried to color code it here, but we should have a right angle, a straight angle, an acute angle, and an obtuse angle. And I'll let you look at those pictures there if you want to see which ones were which, but you should be able to tell really easily that, you know, the small one's acute, the larger one is obtuse, the straight one is straight, and the one that makes 90 degrees is always right. Okay, a couple other terms here. Sorry, I thought we were almost done, but there is just a little bit more. The last term here is congruent angles. And remember, we use this symbol to mean congruent. So congruent angles. These are two angles with the same measure. So any two angles with the same measure are congruent. Like here we have 25 and 25. Let's talk about this one real quick. I had a lot of students have trouble with this my first year teaching, so I added this in later so we can all see. Here's the idea. It says draw an X to the right. Okay, so we're going to draw an X. And it says label the vertex B. That's going to be this corner right here in the middle. We'll call that B. And then it says, and place points A and C on the top. So A, C. And D and F on the bottom. All right. And then it says, hey, ABC is congruent with DBF. So here's how we draw that something is congruent. We do a little kind of just half circle, part circle in there. So ABC and DBF, they are congruent. And then in fact, if we wanted to, we could also say that these two angles here are congruent. And since they're a little bit different, we do these double hash marks. So what we're saying here is that these two angles are the same and these two angles are the same. That's how we would mark that in a drawing. Now that we know that, it says, hey, if ABC is 6x plus 2. And if we want, we can even write that in here. 6x plus 2 degrees. Okay? And DBF, this one is 8x minus 14 degrees. Find the actual measurements. of ABC and DBF. Okay, here's the deal. If these two angles are the same, if they're congruent, then we can set them equal. And that's how you start this off. You would say, hey, I know that angle ABC is congruent to angle DBF. And so that means that their measures are the same. So we could go ahead and just plug in their measures. So this one is 6x plus 2. And DBF is 8x minus 14. And so we know they're congruent, therefore these things are equal. And now all we have to do is just do some algebra and solve. So let's just do this real quick. I'm going to subtract 6x, subtract 6x. I'm going to add 14, I get 16 on this side, I get 2x on this side. Divide both sides by 2, right? To get the x all by itself, and we end up with x equals 8. Okay. Well, they want us to find the actual measurements of these angles, so what we need to do then is plug in that 8. We can kind of do this in our head, right? What is 6 times 8? Well, it's 48. Plus 2 is 50. So that means that angle ABC is 50 degrees. Now, we already know that these two things are the same, so this should end up being 50 as well. So we could just double check. We plug in an 8 again. 8 times 8 is 64, and sure enough, 64 minus 14 is 50. So we could say, hey, an angle DBF is also 50 degrees. Now, that's what they really wanted us to find. And I'm going to tell you right now, I'm going to give you questions where I ask for the measurements of ABC and DBF. And you're going to get here. And you're going to think that you're done, because this might be one of your answer choices, right? One of your answer choices might just be, hey, 8. But 8's not really an answer. This is your answer. The actual answer to the question is 50. 8 is some information you need to get to the answer. So be aware of that. All right, for you guys to just try on your own, here we go. The summary. Using your drawing above, what do you suppose the relationship between ABD and CBF is and why? And I kind of already talked about this. So just kind of tell me what you think is the relationship of those two angles.